Okay. Okay. Are we back? Yeah, we are back. Are we back? Yeah. Uh, technical difficulties. By technical difficulties, what I mean is that the fucking internet stopped working out all of a sudden. Uh, I don't know. No idea. But okay, at least we are back. At least we are back. And hopefully the fucking okay, the fucking ISP will not make us any trouble anymore. Okay, that's it. That's it. That's it. Let's continue. Uh, this. Yeah. Up your game fundamental skills 7 minutes ago. 9 minutes ago. Why was I even here? Yeah, I was reading a nice article by Ruslan regarding. Can I ignore the newsletter? Yeah. Regarding the interpreter that he built. I like this. I really like this. And I don't know, maybe I'll take a look at it next time. Not now. Ah, here it is. Ruslan. Yeah. So, I was stopped. I was interrupted the last time by the internet provider. Here, we are solving this question. Change the grammar to recognize operators written in textual form. And as I mentioned, I think it will take a lot more time for me to write it over. So basically, I'll just give my idea on how I would solve this. I will give my idea in a high overview level, so to say, and hopefully it fits the narrative of the solution that we are seeking here. Basically, what I think will be the solution for this problem here is basically just adding a new operator language description, and I will call it like textual operators, and we will have symbolic operators, and then we will have an operator which will be either a symbolic or textual operator. Let's see if this is the solution. Change the grammar to recognize decimal numbers such as 0.01. This. No. Change the grammar to recognize. Okay. Change the grammar to recognize operators written in textual format, add, sub, multiply, and division. Sorry. Okay. So I think I misunderstood the question. So basically here it says change the grammar to recognize operators written in textual form. What about if we want to use both textual format operators and symbolic operators? Yeah, or something like this. I think my solution was a bit more it took a bit more steps to come to the solution. Just a second, let me check something. Oh, okay. Okay. And what's the next question? Change the grammar to recognize decimal numbers. Change the grammar to make the operators written conventionally between two expressions, and use the grammar from the previous chapter to parse dog. You must add start and end of input. Change the grammar to recognize decimal numbers. So in this case, most probably we'll need to replace the number definition. Okay, let's do this. So change the grammar to add recognize decimal numbers. Change the grammar to recognize decimal numbers. A decimal number has this format, 0.07. The 0 at the beginning is more or less optional, but you can also have something like this or something like this. So what we will have a fraction, we will have the dot sign, and we will have the decimal values. So it will be something like number will be from 0 to 9, right? Yeah, multiple, and it can start with a minus. It can start with a minus. Yeah, it can. It can start with a minus, which is an optional minus, and 0 to 9 is also optional, right? Yes. Then you have the dot, which is just the symbol for the dot. Okay. Oops. And then we'll have the fraction, which will consist of only positive numbers and will require at least one of them. So it will be a plus, right? Let's see. Let's see, what do you say? Change the grammar to recognize decimal numbers such as 0.01, 5.51, or 10.2. Or we can do it like this. But is this even a valid solution? Because you used the regular expression to match both integer and decimal numbers. Okay, I mean, I'm fine with it. I don't have any complaints. I was just wondering. Let's hit the next chapter in the book. It's called Evaluation. It's chapter 7. So it says, now we can read input and we have it structured internally, but we are still unable to evaluate it. Which makes sense. Parser, test. So it's not real, but this is real. It's a valid sentence in the language we created. But we have no proper way of utilizing it and evaluating it. So in this chapter, we add the code that evaluates the structure and actually performs the computations encoded within. It's a pretty photograph. It's an abstract Christmas tree. I can see it. Some parts look similarly. This internal structure is what we saw printed out by the program in the previous chapter. This internal structure, it's called an abstract syntax tree, and it represents the structure of the program based on the input entered by the user. At the leaves of this tree are numbers and operators, the actual data to be processed. At the branches are the rules used to produce. Sorry, just a second. It represents the structure of the program based on the input entered by the user. At the leaves of this tree are numbers and operators, the actual data to be processed. Okay, I think I'm leaving the fog now. I think I know what is being written in the book. At the branches are the rules used to produce this part of the tree, the information on how to traverse and evaluate it. Before working out exactly how we are going to do this traversal, let's see exactly how this structure is defined internally. Ooh. If we peek inside mpc.h, we can have a look at the definition of mpc AST. What is an abstract syntax tree? Oops. An abstract syntax tree is a hierarchical tree-like representation of the abstract syntactic structure of source code written in a programming language. It's a hierarchical tree-like representation of the abstract stat. Each node in the tree represents a construct occurring in the source code. The tree abstracts away certain syntactic details to focus on the structural and semantic aspects of the code. Okay. Before working out exactly how we are going to do this traversal, let's see exactly how the structure is defined internally. If we peek inside mpc.h, we can have a look at the definition of mpc AST, which is a direct data structure we got from the parse. What do we have here? We have struct, which has a car pointer, which has another character pointer, which has a state, children, which has a children, which are pointers to pointers. Okay, so it has a number of fields we can access. The first field is tag. When we printed out the tree, this was the information that preceded the contents of the node. when we printed out the tree, this was the information that preceded the contents of the node. It was a string containing a list of all the rules used to parse that particular item. For example, expression, number, number regex. Ah, so I think this is it. This tag field is going to be important as it lets us see what parse rules have been used to create the node. The second field is contents. This will contain the actual contents of the node, such as this. You will notice for branches this is empty, but for leaves we can use it to find the operator number to use. So we have an operator. Cat parser, let's see. Okay, what I assume is happening now here is, first of all, we are printing. If you are not aware what we did, we created a language using the Polish notation, and here we are printing the output of the parsing of the result. Right? Yeah, we did. So I'm trying to understand. So this is the result of the parse. We are parsing a standard input using our input. This is the language that we created, right? It's called Lisp. And we will store the result dynamically at the memory position of the variable. Okay. Like, I understand some things pretty good. The others are a lot more complex, but I think this is the fight that people usually have with knowledge. It's never easy. It's hard, and you need to do time in order to completely understand it. The second field is content, the next field is state. Is contains information about what state the parser was when it found this node, such as the line and the column number. Okay, we won't make use of this. Finally, we see two fields that are going to help us traverse the tree. These are called childrenum and children. The first tells us how many children a node has, and the second is an array of these children. The type of the children field is a double pointer type, of course. It isn't as scary as it looks and will be explained in greater detail in later chapters. Okay, let's ignore it for now. For now, you can think of it as a list of the child nodes of this tree. We can access a child node. Oh my fucking god, what's this? We can access a child node by accessing this field using array notation. This is done by writing the field name children and suffixing it with square brackets containing the index of the child to access. For example, to access the first child of the node, we can use children 0. Notice that C, okay, I know this. Because the type is a pointer to a struct, there's a slightly different syntax to access its field. We need to use an arrow instead of a dot. There is no fundamental reason for this switch. Fuck. Now this is the chapter. Now this is the chapter which creates a lot of head scratching for me. For some reason. So let's re-evaluate it. Let's reread it. We can access a child node by accessing this field using array notation. This is done by writing field name children and suffixing it with square brackets containing the index of the child to access. Okay. Because the type is a pointer to a struct, there's a slightly different syntax to access its fields. We need to use an arrow instead of a dot. No reason, so just remember. Okay. Let me just ask a question here. How is an abstract syntax tree related to let me rethink. How can I phrase this? Related to writing a parser for a simple language such as the one above. First stage involves converting the input source into tokens, and then we parse these tokens to check if they conform to the grammar of the language. Given the language defined in your code, here's how an AST might be constructed. So we have the grammar here. We define the grammar here. The lexer reads input like add 1, 2 and produces tokens. So the tokens are operator add, number 1, number 2. syntax analysis. The parser processes these tokens according to the grammar rules and constructs an AST. And during parsing, nodes are created for each construct. What's a construct in this? Context. This nodes are created for each construct. For example, the expression rule might produce nodes for them. Okay. Okay, I think I get it somehow. So we created an abstract syntax tree here. We named it A. It's the output of the result structure. Printf. So A is okay. Let's do this. Let's. So what do we have here? We have a tag. We have some contents, and we have some children. Oh, we have a chapter. We have a chapter on recursion. There's another thing about this tree structure. It refers to itself. Each of its children are themselves trees again, and the children of those children are trees yet again. Okay. So basically we can repeat structures, and we can actually analyze structures by dividing them into substructures, and each of these substructures can be divided further, like the Russian babushkas, until we came to the base case, which is, I don't know, a grammar rule, which is a simplistic grammar rule, which isn't constructed of any other rules. Yeah, this mentions recursion. A recursive function is one that calls itself as some part of its calculation. It sounds weird for a function to be defined in terms of itself. We can write a recursive function which will count the number of nodes in our tree structure. To begin, we work out how it will act in the most simple case, if the input tree has no children. Yeah. So basically we have the base case. Let's say we have I don't know, this is an array. And we are doing some calculations by breaking the array in half and doing the calculations only of these three elements, and then only of these three elements separately. And then we can break this even further, maybe like this, maybe like this. Now this is the base case. If we reach this base case, we need to bubble up. And this is basically how recursion works in a nutshell. Let's write this code. Let's see what will happen here. we can create a method that says, oh, what are the number of nodes? And what will we provide? We will provide an abstract search tree. Okay. And here, if the abstract search tree, the number of children is equal to 0, return 1. If the number of children is greater or equal than 1, oh, we'll have this. Wait, so if the number of children is greater and equal than 1, why did he set the total 1? Ah, because we have at least one child. So we can do this. We can access the iterate through the childrenums. Do this. And the total is the total plus number of nodes, which is this, right? And then we return the total here. Is this a solution? Let's see. Let's see. Let me just see something. So number of nodes, return total. How do I undo? How do you undo in Vim? Okay. I don't need these many information. The only thing that I needed was the first sentence. Okay, what about O? Okay. Number of nodes. This. No, actually, I need an abstract search for this, not the result. Just a second. And the abstract search tree A is this. Like this, right? And now, can I just print here, maybe above? Total. So it's a number, right? It's a number. And total. Q clear. I need to parse it again. Okay, we have an error. Where? Vim. Let's see what does it say here. Ah, yeah. Yeah. Oh, okay. Only give me the answer. How to remove a single character in Vim and enter edit mode immediately. X. I'm sorry. I'm sorry. X. Okay. What the X? Why? Okay, undo X. Insert. Okay. Thank you. Thank you. We have another issue now. It says here, in function number of nodes, control reaches end of non-void function. It's line 39. I don't get this. So what does this mean? What does this mean? Number of nodes, control reaches end of non-void function. Control reaches end of non-void function. Why? Why do I get an error saying okay, the function doesn't have a return state. I assume this. You need to ensure in all code paths. Wow. C, you are a weird programming language. Okay. Parser plus 351 segmentation fault core dumped. What does this mean? Yeah, I think I know what the issue here is. I think check for null pointers are not null before accessing them. Clear Vim parser.c. So what I assume the issue here is this, right? I need to add a pointer here. No, it's not. X. What? You hit the free plan limit for G. Why? Don't I have like a subscription here, right? Get plus. I have plus. Manage my subscription. Okay. Ah, damn, I don't have money on my card right now. Yeah, it's today. Today I need to pay it. Okay. It's something to remember. Something to remember. So I have a problem here, and the problem is I get a segmentation fault error for some reason. To evaluate the parse tree, we are going to write a recursive function. But before we get started, let's try and see what observations we can make about the structure of the tree. We get a simple try printing out some expression using... Okay. Why is this done? Okay. Let me ignore this for now. And let's finish the chapter. Okay. To evaluate the parse tree, we are going to write a recursive function. Okie dokie. But before we get started, let us try and see what observations we can make about the structure of the tree we get as input. Try printing out some expressions using a program from the previous chapter. What do you notice? So this is a regex. It's an operator. Okay. It's an operator and it's a character. Next thing. So we have the token 10. It's an expression. It's a number. And we get the number by using by matching it against a regex. So it's an expression. It's a number and it's a regex. Okay. What next? We have an expression, which is a character. Oh, it's this character, right? An expression is starting here. Then we have an operator plus. Then we have, okay, one observation is that if a node is tagged with number, it's always a number, has no children, and we can just convert the content to an integer. When we evaluate our tree, just like when counting the nodes, we'll need to accumulate the results. To represent the results, we'll use the C-type long. Okay. 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 Sorry, let me just try to read it and understand it now. Hmm. Okay, let's take a break. I will come back and we will continue doing this. If not today, then definitely tomorrow. I need to understand this also a bit on my own. actually, I'm not. I will create a stream when I start learning it, so we can do it together. Thank you all for watching, and